In this lesson, we're going to talk about solving absolute value equations. Specifically, we'll understand what absolute value is, we'll solve for the unknown, typically x, in an absolute value equation, and we'll learn how to check your answers. First, absolute value is the distance a number is from 0, and it's written in the form absolute value of x equals some number. These two bars denote absolute value. So when we say that absolute value of x equals 4, we're saying the distance from 0 is 4. So I have a picture of the number line. If we start at 0 and go to the right 4, we have 1, 2, 3, 4. And if we go to the left, 1, 2, 3, 4, we end up with two values that x could be. X equals 4 and x equals -4. If we were to check our answers, we would plug it into the original equation and get 4 equals 4. And if we check -4, we get 4 equals 4 again. So solving absolute value equations, we're going to isolate the absolute value bars, then we split it into two equations, much like what we saw here with x equals 4 and -4. We'll solve each equation for the unknown variable, usually x, and then we'll check your answer. A couple of things to remember. Absolute value bars cannot equal a negative because remember, absolute value denotes distance, and typically there are two answers. Example 1, solve for x. So first we'll start with isolating the absolute value bars. So we add 6 to both sides. We have absolute value of x, because we haven't done anything with that yet, equals 17. Now, just like on the last problem, we're saying the distance from 0 is 17. Or if you split this into two equations, we have x equals 17 and x equals -17. If we're going to check our answer, I'm going to check x equals -17 because sometimes there's confusion on what can and can't be negative with absolute values. So when we check our answer, we always plug it into the original. So I'm going to say absolute value of -17 minus 6. I want to know if that's equal to 11. The absolute value of -17 is positive 17 minus 6. Is that equal to 11? 17 minus 6, we end up with 11 equals 11. So our two answers are 17 and -17. Example 1, part B, solve for x. So here we have absolute value of x equals -2. If I were to draw a number line, we're saying that the distance from 0 is -2. Now don't confuse distance with position. This is at -2, that's its position, but it's not -2 units away from 0, it's 2 units because our distance is positive. So in this case, the answer is no solution. The temptation here is to say that x equals 2. But if we were to try that, we'd have absolute value of 2, and then we get 2 equals -2, which is not true. Another temptation is to try x equals -2. But again, if we try that, we would have absolute value of -2 equal to 2 equal -2, and we'd end up with 2 equals -2, which is not true either. So this is an example of where an absolute value equation has no solution. Example 2, solve for x. So again, we'll start off with isolating the absolute value bars. Now take a note at the difference between the problems. This has absolute value of x minus 5, and then -7 on the outside equals -1. So it's different from the last problem because we had our absolute value bars isolated on one side equal to a negative. Before we can determine if there's a solution or not, we need to make sure the absolute value bars are on a side by themselves. So in this case, we'd start by adding 7, and we'd have x minus 5 equal to -1 plus 7 is positive 6. So we have our absolute value equal to a positive. We can continue on. This is when we split it into two equations, and the principle comes from the very first slide where we had absolute value of x equal to 4. So if we split it into two, we have x minus 5 equals 6, and x minus 5 equals negative 6. And we solve both of the equations for our variable. Add 5, x equals 11, add 5, and x equals negative 1. So these are our two answers. Again, x is allowed to be negative. What we can't have is absolute value, which is distance, equal to a negative. And you can check your answer. And again, I'm going to check x equals negative 1 just to reiterate that the value of x can be negative. When you check, you plug it into the original problem. So we'd have negative 1 minus 5 minus 7, and we want to know if that's equal to negative 1. Negative 1 minus 5 is negative 6, minus 7 equal to negative 1. The absolute value of negative 6 is 6, minus 7 equals negative 1, and we get negative 1 equals negative 1. So our answer checks out. Example 2, part B, solve for x. So in a problem like this, when the absolute value bars are already by themselves on one side of the equation, you can go right into splitting it into two equations. So this would be 4x minus 16 equals 12, 4x minus 16 equals negative 12, and solve each for x. So add 16 to both sides, and we get 4x is equal to 28. And we'll add 16 to the other side and get 4x equals 4. Now from here, we're solving both for x. Divide by 4, and we get x equals 7, and divide by 4 to get x equals 1. So these are our two answers. And I'll leave it to you to check both of them. Example 3. Sometimes there's some confusion when we have something set equal to 0 in an absolute value equation. Okay, we follow the same steps that we did before, where our goal is to isolate the absolute value bars first. In this case, negative 4 is being multiplied. Okay, when you have two things next to each other like this, it denotes multiplication. So in order to isolate the absolute value bars, we divide both sides by negative 4. So we have negative 4 divided by negative 4 is just positive 1. So we have absolute value of x equals 0 divided by 4 is just 0. Now you can split this into two equations, but there's not really a negative 0. So in this case, we can determine that x is equal to 0. So this is a case where there's only one solution. And if you wanted to plug it back into check, we would plug 0 into the original. And absolute value of 0 is 0, negative 4 times 0, and we end up with 0 equals 0. So the answer checks out. Next, example 3, part B, solve for x. So looking at part B, we have negative 5 being multiplied by absolute value of x minus 4 equal to negative 60. Again, we isolate the absolute value before we determine if there's a solution or not. We divide both sides by negative 5, and we have absolute value of x minus 4 equal to negative 60 divided by negative 5 is positive 12. So we have our absolute value equal to a positive number, so we can continue on. We split this into two equations and solve each of them for our unknown variable x. So we have x equals 16 and x equals negative 8. Again, I'll leave this problem to you to check your answers. Thank you for watching. If you have any additional questions, please feel free to contact me for assistance.